Okay, welcome back. So this is our last video for Wednesday. I didn't get to this in class, so everybody should be watching this one. Often people invest money. They have a goal for which they want a specific amount of money at a future date. The principal that is invested is called the present value of the investment. The present value that will result in a specific amount with accumulated interest can be calculated by rearranging our first formula. Or it looks like this. So you can remember another formula. So this one, present value equals amount over 1 plus I to the n. And remember, when we have something in the bottom, we can make that a negative exponent. Let me just make this bigger a little bit. So see how we have a negative exponent here? So remember, a negative exponent means to bring it down to the bottom. So this is simply a over 1 plus I to the n. And you'll notice that that was the first one that we came up with here. So PV is the present value, the value that must be invested or borrowed today. A is the amount that you want to have at the end of the investment. I is the interest rate per compounding period, the effective interest rate. And N is the total number of compounding periods. So let's take a look. Tom would like to have $10,000 in an account in 9 years. He wants this in 9 years. That is a future value that he wants to have. How much should he invest now? So the question is really a present value question. How much should he invest now so that he can have a certain amount of money in the future? That's your formula. Oops, you can't see. Let me come out a little bit. So there you go. Okay, let's put down what we know. We know that the present value is what we're looking for. The amount we want to have in 9 years is 10 Gs. The effective interest rate is 5.75 per annum divided by 2, compounded semi-annually. So the number of compounding periods is twice a year for 9 years, which is 18. Okay, so 5.75 divided by 2 equals, divided by 1,000, not 1,000, divided by 100, I goofed. So 5.75 divided by 2, divided by 100, and that gives us 0.02875. Putting our stuff into our formula, we're going to have 10,000 over top of 1.02875 to the 18. So, a couple ways to do this. I can start off with 10,000 divided by 1.02875 to the exponent, 18, equals, and we come up with $6,003.75. Now notice that it's actually a little bit more. It's 75 cents and a tenth of a cent. Since the bank isn't going to give us a little bit more at the end, we have to put in a little bit more so that we ensure that we have the right amount of money. So you're actually going to round that up. Otherwise, you'll have a little bit less than what you wanted. This way, you'll have a little bit more. Okay, there's another way to have done that question, though. We could have done the formula being present value equals A, 1 plus I to the negative n. It's the same formula, in which case it would have been 10,000, 1.02875 to the negative 18. On a calculator, that would be 1.02875 to the exponent 18 negative equals times 10,000. And we get the same answer. So it doesn't matter which formula you use. It does matter how you use your calculator, so be able to do both. Okay? Our school board is planning a fundraiser event to help them finance a trip to England in 3 years. The band, not the school board, sorry, the school band. The band plans to invest money from the event for 36 months at a high-risk mutual fund that has an estimated return at 4.5% per annum. That's really good. That's a lot of money That's why it's high risk. It'll either make it or it won't. Kind of risky. It's going to be compounded monthly. Okay, so every month, interest is going to be added. The band hopes that the money from this event will provide $8,000 towards the cost of the trip. So the question is, how much does the band need to raise now and invest to achieve this goal? Okay, so they want $8,000. They're going to invest it for 3 years. It's going to be compounded monthly, and the interest rate is 4.5% per annum. That is how much does the band need to raise now? This is a now question. So, and how much is it? Or what is the formula, sorry? Present value equals A 1 plus I to the negative n. I'm using the other form of the formula just because I can. So, the amount, that's the amount that we want to have, $8,000. I, it's 4.5% per annum divided by 12 because it's monthly. So 4.5 divided by 12 divided by 100 is, now my calculator shows that weird, so let's see, I just got a 3.75, it's going to move 1, it's going to move 2, it's going to move 3. So let's see if I multiply that 1, 2, 3 times 100. Yep. So it's going to be 0.000375. Now that looks a little bit weird. Let's make sure that it works. So if I take that number that I had in my calculator, and if I times it by 100, and if I times it by 12, I get back to my 4.5, so we're good to go. Okay, next, N. N is 3 years times 12 times a year, so that's 36. So it's 8,000, 1.000375 to the negative 36. So 1.00375 to the exponent 36 negative equals times 8,000 equals, they need to invest $6,991.49 and a little bit. So it really should be $6,991.50. They invest that now, and if they get this interest rate, and if they leave it in for 3 years, and if it's compounded monthly, they will change the $6,991.50 into $8,000. All right, that's it for me. Your turn. Extra practice, page 400, 9 and 10. Get that done for tomorrow. Let's see what we're doing. We'll see you then.